So it's starting.
You are live.
Okay.
All right. Good luck.
Can you see like 10
What's
million eyeballs?
What's that?
10 million eyeballs.
I don't think it's that many, unless we have a whole bunch of people with compound eyes. Count to 20.
Could be.
Could be. What did I say?
Could go. Nothing, huh?
You're gonna need that. I think we'll give another 3 minutes for people to realize they're allowed back in. Then the fire alarm will go off again.
People are still coming up and rooms are still unlocked, so.
This is possible for the web.
Presumably, yes. In fact, let me hook it up for me too.
Make sure it works. Well, you're effectively seeing it. Perfect.
That was dumb luck. Good. This is good.
It's going to be in 3183, which goes there for left, and first on your right.
Yes.
I found this one first.
Is that how it works?
Yes, I got lost. It's a room. It's got some people.
Good.
Use whichever one you want to be in.
I'll take yours.
No? Okay. In the meantime, we use the version control system for the
All right, we'll start in 1-2 minutes.
Oh, boss stage is licensing is sometimes length isn't high speed, or they do like
Okay, so we just got the all clear. We're probably good. People are back in from outside. Thanks. This was a wonderful start to our day. For a while, we were thinking about perhaps just doing like out in the mound. We go to a little grassy area, do it like amphitheater style. But none of the presenters figured out these slides quite right. So my name is Bri Hatch. This is Git administration, hooks and dangerous things. The dangerous things can be kind of left up to the imagination at the end. Anything can be done with code, right? Git. How many people here have used version control of any kind? Who here has used SCCS? Youngins, all of them. There have been many different revision control systems over the years. There's, one of the most common first ones was RCS, CBS, Subversion. We're not looking for you rah-rahs here. CBS! And the answer was, it was better than the previous things. Each one of these things was better than the previous episode. It was better than CBS. It was better than CBS. See me after class.
Yes, but we could make aliases so that we could run SVN with all of our old CBS codes and didn't have to get confused.
There was much fun to me. There was the original version is, we got files in a local directory. I'm the only one who could touch it. We got into bigger systems where multiple people could work. There was a server-side component. Then we got in really distributed versions where there are multiple servers out there. We're not going to be talking about how you do Git stuff. We're not going to talk about how you add files, how you do diffs, how you do commits. We're going to assume that you already know that. And I'm going to actually show you from the administration standpoint how you set up a Git server that you can do your commits to and have other people do so as well. There are a bunch of different ways of skinning this cat. A bunch of ways to skin this cat. The program that I use currently is called Gitolite. There's also been things like Gitosis. There are lots of bigger tools you might have, like Staffs or GitHub has a free version of their stuff you can run. all these things do similar things. Gitolite is pretty small, pretty self-contained, pretty configurable. The way that Gitolite works, the way you have multiple people working in a project, is you essentially have a special account on that machine. Typically, it's called Git. People will log into that machine using Git commands. You set up the authentication using a thing called SSH. SSH is the same thing you use when you say, I want to go from my machine to this other machine and log in. SSH is the tool you use when you're actually SCPing files. SSH is the protocol we're using FTP to FTP files from. So Gitolite helps create the repositories, because you can have multiple repositories in a box. Automatically does the work of configuring SSH for the keys for your users, such that all they can do is the Git stuff you want them to do. They can't log into your box. They can't get a shell. They can't, snoop around in Etsy. It sets up the policy requirements that you have, so you can know this person can make changes to this repo. This person can't touch this repo at all. It also allows you to write server-side hooks, things that happen automatically when somebody is pushing up code to the repository. So those are the big things that Gitolite does. It actually can also do stuff over HTTP or HTTPS if you want. I actually don't know of anybody who does that. Everybody I know who's using it uses it with SSH. So I'm not even going to cover the other stuff, except for this guy apparently.
Corporate firewall rules.
Corporate firewall rules, which I generally get around. Yeah. Do we have a clock here, by the way? I'm going to try to. There we go. I'll try to see if I can not go too much into the time we lost due to the fire drill. So Gitolite installation. You may have a version of Gitolite available already in your distro. If you don't, then you start off with this. This is how you can literally grab from the Gitolite source code out there. It's, unsurprisingly, in Git. So the first thing, you probably want to have some user that is the Git user, the person who owns the repositories. Typically, it's called Git. So let's become the Git user. So sudo su -git. Set up that user if he doesn't already exist. Make a bin directory for him. Clone the Gitolite source code from the upstream repository. Once it's in our repository, there is a install script that's in there. It will build up all the pieces it needs. Tell it where you want its binaries to go. In this case, we're throwing it in Git's personal bin directory. And then the very first thing you do after that is you have to set it up. It has to have somebody who is the owner of this thing to start. So you have to have some pub key, some SSH pub key that's going to be you. So presumably, you've already made one. The program SSH keygen is the program you would use if you don't have one. Normally, these things are called ID_RSA or ID_DSA inside your SSH directory in your home directory. So create a key if you don't already have one, or maybe make a special one that you want to use just for Git. You, by virtue of setting this up, you're essentially the root user, the main user. Whenever you have this named, in this case me.pub, that's what you're going to be called inside all the configs. So probably you want to use your username. So I would use Brian. If you already have Gitolite available in your software installation distro itself, then you might be able to just be lazy, apt-get install it. So this is how it's in 1204 Ubuntu. Or I'm sorry, it's also in 1404. GL, Gitolite setup, and again, you give it that pub key. It'll set it up for you. If you're using the older 2.x version, it'll pop you up into VI, unless you're unlucky and you get Emacs or Nano or something like that. I hear they consider those editors. And there's a big config file that has stuff. If you're using an older version, you'll see this. You don't really need to change anything, but you have some parts you can if you wish. In Gitolite 3 and later, it doesn't pop in there at all. It just does a sensible thing, so you can change it manually. In order for it to let you start using it, you will be managing Gitolite on the server by checking out the Gitolite repository, making changes and pushing them up. So it has to make sure that you, this new user, can actually log into the Git user. And so it's creating an entry in the authorized keys file. The way SSH works is a user in their home directory might have a .ssh/authorized keys file. This lists the keys that are allowed to log in without typing a password. So it took the pub key that you gave on the command line earlier, and it starts right here. This is from the file of the pub key itself. So it's copying that into the authorized keys file. all this stuff at the beginning of the line is the way that it is making sure somebody can use this key to log in, but they can't get bash, they can't do ls, they can't look in Etsy, they can't copy files. This first part, command equals, says when this key is used, don't care what they tried to do, you are going to run the Gitto-like shell program. So if they were trying to SCP, SFTP, SSH space, host space, ls, doesn't matter. What they actually end up running is the Gitto-like shell. These other bits here, no port forwarding, no X11 forwarding, no agent forwarding, no PTY, some additional SSH restrictions. This means that if they try to SSH port forward, it'll deny them. If they try to, actually do an X11 forward, it'll deny them. Just trying to restrict what this thing can do. So all this is created automatically by the fact that you had made your first Gitto-like config with the GL setup or the Gitto-like setup. So where does this stuff live on the server? Yeah.
Sorry, the example that you had just a moment ago with the one that.
Yeah.
One more.
One more. I can keep going.
No, right, that's good. The meetup hub, is that an existing public key that you have
Yes.
already? Okay.
You'd have to have a pub key to set it up. Otherwise, you won't ever be able to log in to do your stuff. And again, you probably want to name it something other than just ID_RSA. I'd call mine Bry or Dathmir. Those are the names I go by. Say, on the server, where does stuff live? In the Git users home directory, you're going to have a gitolate.rc. That's a config file. You don't make many, if any, changes to that. There are a couple places you would, and I'll show you those when we get to them. There's a .gitolite directory inside there. Essentially, the Gitolite admin repository gets checked out inside that .gitolite directory. That's where it does all its work. That's where it reads its files to know if people are allowed or not. The SSH authorized key file, as mentioned, that's where it's going to be putting in all the keys of the people you're allowing in. And then all of the repositories directories live in Git's home directory in a directory called repositories. If you want to change these names, you shouldn't. It really just assumes that's where they're going to be. You can symlink them away. As long as you keep the original name, it'll work.
So the only data that's not checked in is the .rc and the authorized keys?
The .rc and the authorized keys, but the authorized keys is automatically generated, so you don't lose anything if you lose that file.
And, sorry, but most of the stuff is checked in like it should be, correct?
Yep. Because revision control is
Yes.
good. So first step, I'm the administrator. I want to be able to start making changes. I want to be able to say who gets access. I want to make some repositories. So the first thing I do is I clone the Gitolite admin. So this is me on my desktop here. Okay, just $sign. So git clone, what's the protocol? SSH. Who's the user? Git. What's the machine? It's called server. Pick something better in your office. And the repository is gitolite-admin.git. So go clone that repo, copy here. If I go and cd into there, what are the files it has? Oh, a heck of a lot. There's the configuration, gitolite.conf. And there's one thing in keydir called me.pub. That's the pub key I made. That's the one that allows me to get in here. So let's look at a default configuration file. You have lines like this that say repo. The style that they use in the docs and stuff that I try to stick to more or less is try to line things up. Again, it's up to you how you do it. So here's a repo line. Here's the Gitolite admin repo. This defines that there should be one. If there wasn't one, it will get created. You then have a bunch of lines that say what permissions can be done by what users. So RW plus, read, write, and more is allowed for me. We have a repo called testing. Read, write, and more is available to @all. @all is a magical group. It's every single defined user, which right now is just me. The users are defined by virtue of having a key inside that key. So let me jump over on the server here for a second. So if I look on the server and I look at the repositories directory, we see a Gitolite admin git and a testing git. Again, by default, it created this configuration, it created those two repositories. These are full Git repositories on the other end. They're bare, they don't have it checked out, if you understand the difference there. So it's a little bit more efficient, but all the data's there. So let's go and add a new repo. We can even delete a repo, but let's start with adding. So we're going to leave this exactly as it was. We have the Gitolite admin, we have the testing repo. We're going to say, okay, repo, foo project. we're going to give read-write access to me. That's the me.pub that's in the queue. Let's commit that. So commit -a means commit all changed files. -m means I'm too lazy to jump into an editor. Here's the commit message I want. So as new food project repo, and then git push out. Maybe I should have done a git pull just because, but I knew it was just me. On the server at that point, what you would see after the push is done, after it pushes up to the repo, you will now see a food project git and existing Git-O-Lite admin and testing git. So creating a new repo literally is just saying that there's a new repo and defining who has what kinds of access to. So you don't have to worry about jumping in there and doing a git init, oh shoot, git init bear, that's what I meant, and all that work. Just define that it exists. It'll get made as soon as you push out the changes to the Git-O-Lite admin. Any questions thus far? Okay, let's add a new user. Right now it's just me. That's not a lot of help. It's not very distributed. It's just too personal. Let's have other people help out. Okay, so let's say somehow or another I get a copy of a pub key for XLR user. Maybe they send it to me in email. Very secure. Maybe I pull their pub key out of their home directory's SSH because it's readable, because it's a pub key, and it's on an NFS share, so everyone can see everyone else's home directories. Maybe I'll pull it out that way. Whatever I do, I manage to find the pub key for XLR, and I'm going to copy that into keydir as xlr.pub. That name inside Git-O-Lite admin is XLR. That's their name. Again, you probably want to use something identifiable like, say, username. A consistent username scheme, use that. Don't say Paul unless Paul says username, so there might be 10 Pauls. So I copied in there, git add keydir xlr.pub. I have to tell Git this is going to be added the next time I do a commit. I made a change. I apparently didn't show that. So let's look at the conf, Git-O-Lite conf now. And I have added to the foo project another RW line. Read-write is available to XLR. And if I look at the keydir, I can see that there's a me and there's xlr.pub. So they're both there. So I can do another commit, commit -am. A again means commit all the things that are changed or new that I've said with git add. -m because I'm lazy. Here is the command I want to, the commit message as XLR user with access to foo project, and git there, this is push, but it couldn't quite see it off the end of the screen. Perhaps I will work on word wrap next time. That's all it takes for that person to have access to the foo project. Now, this is great if you want to do one-offs. Each time you add another person, what if you have 500 repositories or 200 users? You probably want to start grouping these things together. The @ sign is where the magic happens for groups. So let's say we want to make a group called web team. So @web team. You're going to put all of your web folks in here. Who's in that? Me and XLR. Incidentally, I like to put these in alphabetical order. I'm kind of pedantic, but it makes diffing it easier. Say, oh, okay, well, there's me and there's XLR, and if I had to add Bob, well, Bob would go at the beginning of the list. So that's who web team is. @crypto team has Alice, Bob, Carol, and Eve. Again, alphabetical is good. Everybody knows Alice and Bob or Carol are good, and Eve is the evil interloper who's trying to figure out what they're doing. So you got two groups. You can make a bigger group, and you don't have to put them all on one line. You can just continue aggregating and accumulating through. So if I had a huge group that had 5,000 people, I don't want a line that has 5,000 people long. You don't need continuation lines. It just continues to accumulate. So @huge group has first person, and then it grabs in second person, and then it grabs in third person, fourth, fifth, sixth, seventh. Yeah.
How do you miss them?
Can you take a group and add a group to a group? You can add a group to a group. So magically expand that. So try to keep it readable, make it diffable. Some people say they don't ever want to have multiple in a line because it's harder to see when you take Bob out what the change was. It's up to you. You can also, if you want, auto-generate this file by querying LDAP. So you could have some wrapper that creates this file by grabbing information from LDAP or Active Directory, whatever, and then create the file out of it. You actually can, if you want, build in LDAP access to this to Git-O-Lite on the server side. To say, okay, this group comes from LDAP by running this particular program to expand out the name I give. A little bit more advanced. So here's my foo project repo again. I'm going to say @web team has read access, @crypto team has read write, and fourth person, just that one person, also has rewrite to the project. When is this going to take effect? When I commit and I push. Okay, so what are the standard permissions? R, read only. RW, read write. RW plus gives you stuff that you technically most people say you should not do on a server that other people are using. It gives you the ability to read write, rewind to revise history, to delete tags and branches. Some people will say, thou shalt never do that. You are changing the history of a shared repository. Other people say, in some cases, it's just fine, just let us do it. So you give this to your dangerous users who you trust a lot.
Come on in, there's a couple of seats in that.
See you guys.
So RW plus gives more permissions to you. You can go and change the history on the actual server. Confusing permissions. I think this is a well-named section here. If you have a RWC somewhere for a repo, then that means they have the ability to read, write, and create. RW gives you the ability to read, write, and create. But if you ever have an RWC or an RWC plus, that means that all the RWs actually didn't have create. Same for D. So if anything has an RWD, then that means all the RWs didn't have delete, but this one does. Or RWM would mean can they or can they not merge. So even though RW normally means read, write, merge, create, and delete, in this case, no. This one has merge, the other guys don't. These, you don't see these used very often. They modify how the rest of it works. Not the best syntax. So let's look at a bit of an advanced example here. We got a repo called website. We've got a bunch of teams who are going to do different things on this website. Check this out. So the first one, very easy. RW equals web team. Web team gets read write. This next line, haven't seen something like this yet. The first thing says dash or minus. And we have another field here, master. You're allowed to say an additional column here that we haven't seen thus far, saying what refs does this particular rule apply to? So in this case, this only applies to master. Master gets, for web team, nothing in particular. It's not adding or deleting, it's just saying this matches. This next line, RW plus, web team gets RW plus. The way that the processing works is it starts at the top and it finds the last match that is an allow. And at that point it stops. So we got a match on web team if they're trying to read or write. If they're on a non-master branch, then this rule does not apply. And if it's a non-master branch, then they get plus. On a non-master branch, they can delete tags, they can rewrite history. So this matches if and only if they're not on master. So this is where you can say, I really don't want RW plus in general. I don't want them changing history on master. Masters are an important one. That one is, the one that's a gold branch is going forward. It's good. But they should be able to make tags and delete tags and branches and delete branches. Those will let them be a little more wild, wild west. So this is the standard idiom to say, read write by normal cases. Here's a branch that you can't do dangerous things, but everywhere else you can. And then for the marketing team, we're going to let them read stuff. Sure, we'll let the marketing team read our web property. But we have a refs tags playground. If there's a playground tag, they can read write for that one. So again, it works down to the last allow match. If it ever gets a deny, then it stops at that point. This field here, where we have master, or in this case, refs tags playground, if you don't start with refs, then it assumes refs / head. So this would be refs heads master. But this way it can be shortened to look just like the branch name itself. So yeah, processing stops at the first allow match, and if there's no allow match at all, then it's a deny. So Bry is not in any of these. It would keep going, fall off the bottom, default deny. You definitely want to play and test these when you're building these more advanced configurations, because they're kind of strange.
Is there a way to expand this to, like, for debugging purposes, to see, like, show me what this rule set created?
There is, not directly, but you can do so by using Gitolite space access, and you say, what they were trying to do and who the user was, and they'll essentially give you a thumbs up or thumbs down why, or do they get access or do they not get access. So GitLite Access does that for you. But then you'd have to try all the things you want manually. But it's better than actually just logging in as each person doing it many times. Which you can do, just make your own test Git repo for it. Okay, more advanced logic. So those were refs. There's a thing called a vref in GitLite. Vref is a virtual reference. And virtual refs, instead of starting with ref, start with vref. And this thing here is actually a piece of software locally installed or inside the GitLite repo that runs and determines, based on this program's arguments, if it is a match or not a match, if they're allowed or not allowed. So you can write arbitrary software here that will let you do more advanced things. You can say, he is allowed unless he is coming from this IP address. Or she can do it except on a Thursday because she's always getting drunk on Thursday. Just don't want someone doing it on that time. We know we're not good engineers. So vref, and then whatever program to run, and then whatever arguments it takes. And that's pretty much beyond the scope of the talk. We won't show any of those. Some of them come by default though. How's our time? Okay. So Git hooks. Hooks are awesome. There are different kinds of hooks. There are hooks that can run when you are doing a local commit on your local branch. You can say, let's make sure that the commit message looks good. I know I'm always forgetting the style, and I put a line, another line, another line. I forget to close out a blank there. Right? So you can do something that happens before you commit. As you commit, it can look at the message. It can say, okay, you're committing too many files. You can also do stuff on the server side. Server side hooks are more limited because all the committing is done. There's nothing left to commit. You're just getting changes to apply to the repo. But the most things you would use Git hooks on the server side, making sure the commit messages meet policy, because you can look at the entire thing before you allow it. Preventing bad commits, for example, if someone's got carriage return line feed. I did my work on a Windows box and I committed, and well, now the line ends are stupid and the guys in Unix were all going to hit you over the head with a bat. Let's just not let them push to the repository in the first place. Sending commit message emails. Some people really like every time there's a commit to send out an email to the mailing list. People see what's happening rather than me saying, oh, I committed this important thing. Just have it happen automatically. You could include just a little bit of the header. You put just a log. You put the entire diff if you want. Automating things on push. This is where it can be fun and dangerous. I do a commit, and that makes things happen. So again, on the server side, it's somewhat limited the options you have. There are 4 different kinds. Pre-receive, update, post-receive, post-update. These happen in order. A pre-receive hook is allowed to see all the old and new changes, and it can either say the entire thing can try to be committed here locally, or it can't. So it's very Boolean. Yes, continue, no you don't. You can decide on each individual piece. So when you do a push, you might push 1 change, you might push 50 changes. So the first one gets to look at all 50 changes and decide overall, am I allowed to even proceed with these, or am I not going to allow it? And of course, put some information back to the user if you set that. Update. Update is, got past pre-receive. Update can now decide on a case-by-case basis, should I allow this one or not? I generally don't like update hooks because I either want the whole thing to see right in. Post-receive. It's been sent to me. I have committed it to the server's repository. I can now do other stuff if I want. And it gets the same info as update did. Post-update is at the very, very, very end. He doesn't know at all what the changes were, but he could run every single time. So if you had something you want to run based on what happened, for example, I need to know what 5, 10, 50 changes were pushed into me and send email about them. You do that in the post-receive because you still have information about what that change was just pushed. Post-update, you don't know what it was, but you could say restart the web server every single time, no matter what. So if you look at the GitLite admin configuration, there are a couple different ways you can do this. What most people did originally is you would go and log into the server and you would put your changes in a separate directory, and that's where your hooks would live. But then it's just kind of silly because then things that are running your revision control aren't under revision control. So later on, they allowed you to put the hooks inside the GitLite admin repository itself, and now your revision control is under revision control. So this would be the place where you would actually modify a GitLite RC file. There are a couple things that are turned off by default. The local code entry. By the way, GitLite is written in this language called Perl. Who admits to still writing things in Perl? I'm sorry. So this is literally read as one big huge Perl variable. So that's the config. So local code tells it where it's going to be. So again, the way I prefer to do it is use the GitLite directory that's checked out. So you need to turn that on, and you want to allow repo-specific hooks. You don't have to. You could have something like hook every single time for every single repository. But I like the granularity to say, okay, this repo needs this, this one doesn't. I don't want all of my repositories to send email. Maybe I just want these 3. So at that point, make a repo-specific directory inside your checked out GitLite config. And I created a couple of different hooks I can run. CRLF check, send email, and update infrastructure. So these are shell scripts, Python scripts, whatever you want to write. Let's take a look at our GitLite conf now. For our host info repository, I'm going to say that I want you to do a post update hook to run the update infrastructure script. Each of these hooks is going to get information about the changes that you just are either trying to push or have finished pushing. And so it'll get old, whatever the ref is, as well as the old and the new change list numbers. So you'll see those SHA-1s, and you can decide what to do with that information. You can ignore it. You can say, okay, I'm looking at specific things in some cases. So for a post-update hook, it's already done writing. Then it'll run the update infrastructure. For the documentation one, I just cannot stand to see this carriage return line feeds. So as a pre-receive hook, as I'm getting the data and haven't committed it yet, see if they have CRLF. And if so, I'm going to say no. For all, so at all again is a special group. It means all of the Skid repos. For all of them, I want you to post update to send out email so we know what changes happened. So here's a trimmed down idea of how the update infrastructure would work. Let's assume that this host, what would I call it, host info. The host info repository has a bunch of DNS stuff and DHCP stuff. We're putting all of our infrastructure info inside Git because we hate manually editing files. We like things in our revision control. And I like to make my change to revision control and say go. In fact, I don't want to say go. I want it to just go when I push. So the way that this one runs, this is a post update check. If you look at the Git, I think it's Git hooks man page, it'll tell you the format of the data you get. Generally, it's your reading lines on standard input. So the line will say the ref, the old revision, and the new revision. You'll get multiple of these as you go. So I'm going to read from standard input the old revision, the new revision, and the ref. So I get that one by one. I'm going to show what that change is. There's an option for Git show that says what format you want the output to be. I essentially am going to show just the names of the files for that new ref. So I committed something, and it says show me all the files that are new or changed. So that's the Git part. Way over there we got a pipe, so I pipe that into grep. If one or more of the names starts with DNS/data, this means I have made a change to the DNS data file. Who here is crazy and uses DJB DNS or has used it or heard of it? Awesome, I'm sorry. I use it too. I love it. It's great. Everything is in one file. And as long as you turn your brain inside out, DJB software makes great sense. Literally, all the DNS data is in a file called data. It's one line per DNS entry, and it says equals hostname : IP address. We'll say here's an IP address that goes with this IP, or the DNS name goes with this IP. Build me all the records that make that work. The forwards or reverse, you name it. So if they've edited the data file, how do I make that go into production? Let's see. Let's just put that in some script called update DNS. So if they made a change of data, then we're going to run some script that does the right work to push that out to production. And this is going to run on the Git server. Similarly, if they have made a change to DHCP conf, so we got some DHCP configuration that we're maintaining. then run the update DHCP script. So when this thing goes, it looks at what stuff was changed. If it matches something we care about, then run some other script. Server-side hooks, doing all the workflows. Okay, so here's a example of how you might do your update DNS. Again, this is assuming DJB DNS, tiny DNS. What you need to do is you need to take this data file and copy it out to the servers and remake the file. So a bunch of variables. Who knows what a set minus e and set minus e means? Set minus e means
Stop on errors.
if you get any of these things at error, die instantly. Great thing to have at the top of your bash scripts. How about minus u? If I have an unset variable that I try to use, if I try to echo $foo and I never set $foo, die instantly. So it helps save typos, and it's an easy way of quitting if there are problems, rather than constantly testing my exit status of each thing. So die quickly, make sure that I'm not typing something stupid. So I've got a bunch of variables here. I'm going to essentially have a local checkout of that get repo. So I'm not going to work off of the real official repository where I'm writing this up. I'm going to have a separate one that's just read-only that I pull out. I got a bunch of variables say where I'm putting stuff to, and it sends stuff out to NS1, NS2, NS3. What user do I SSH out as? So let's see, I'm going to go into my local repo, and I'm going to git pull from it. So at some point I checked out a copy of my host info repository. I'll jump in there, I'll do a git pull, so I get all the updates. One thing that's important here, if you're doing any git work in a git hook, you really want to unset the git_dir variable because it's kind of screwed up. It's set to be part of the hooks that we're running, and it's not going to play well when you're in a totally different repository. So unset that guy, or this guy is going to give you the most esoteric error message. It'll take you hours to figure out. So unset the git dir so you're not still thinking you're a hook, even though you're running in a hook, if you're going to do other git things in other areas. So git pull, bring my thing up to date. Presumably this is the only thing ever doing a git pull there, so it's always going to work. You're not going to have conflicts. So for the host that I have in DNS hosts, NS1, NS2, well, let's SCP that file out there. Oh, it went too far as well. So I'm going to SCP it out from the local repo data using SSH user at whatever host is to the target directory. So copy it out, and then I have to SSH to that machine as that user, and the way DGB DNS takes that file, compiles it into a .cdb database file. So run make in that target directory. So copy the file out, run in there and compile the file to the format that's expected. So voila, this, when you do a push of your configuration to Git, triggers it going off and automatically restarting your DNS servers. You don't have to think. It's kind of scary. You don't have to think. What if you push something bad? You pushed something bad. What if this pushes it out to all 25 web servers with the new web content? I hope you have something that checks to make sure it's going to be good first. Or you could just be dangerous and just do it, because what happens if it goes badly?
You reverse the commit, you push again.
You go to where you had made your change, git revert head, git push. It pushes out the previous version, does all the same stuff, and now you're running the old version. It's great. Live dangerously. What could possibly go wrong? Things can possibly go wrong. Always have a fallback. But yeah, you just git revert the previous change that was bad, push it out, it'll just go back to where it was.
You don't get the thing where, oh, right, it's going dead now because I made that change 3 weeks ago and
Exactly.
I just pushed it now. What was that change 3 weeks ago?
No one remembers. It's now you have the stuff that can break in here. What change did I make last Thursday? Something was different Thursday. It's all in Git again. I love throwing more things in revision control because you can just go and use it as logs of what I did. And it can still send email. It can send an email to the NOC, say, hey, by the way, we just pushed a change. These are the 5 hosts that were added. Again, you can do anything you want. So there's some hooks that come with Git. They're in the contrib/hooks directory. Might also be, depending on your distro, in the Git core contrib hooks directory. So they have one for a sample for sending email. A couple things you might want to do. These are running as the Git user on the machine. It might need to do things like SSH, SCP, run things local. So you very often are not going to want to do things as the Git user. You might want to do the sudo, for example. You might want to change user to do something else. Maybe it goes to the local Apache directory, updates some things, but it needs to restart Apache. Or perhaps it's going to jump over a machine and it's going to restart the DHCP server. So sudo is a way you can take what's running currently as the Git user and run it as some other user. It doesn't have the ability to type its password. You really don't want it to even know its password. So in the sudoers file, you could say the Git user running on whatever this server is allowed to, as root, run etc DHCP server restart. I forgot the no password line in that. I will fix that. Fail. I'll fix that here when I'm done. So that's something you want to do, is make it so it can automatically run something on that local machine as a different user. SSH agent is probably something that would be useful if you're trying to run stuff on other machines, because you can have an SSH key that has no passphrase on it. I always feel oogie about doing that. I'd rather have an agent that currently has my password cached. So some human logs on the machine after it's booted for the first time, starts an agent, authenticates that key into it, and then you hook your stuff to use that agent that already has it in. The machine reboots, the password is still unusable until a human provides it. So again, we don't have something on clear, non-encrypted this. Auth-progs is a good way to say, I have something I want to run on a remote machine, agent, I have a SSH key to allow me in, but I only want it to run X, Y, and Z. These are the only programs I want it to run. Auth-progs can run the remote server, say, here are the things you can run, everything else it will deny. Both of these things are described in a presentation I gave at Linux Fest back in April, if you want to look at it. That's fun Git stuff. Yeah.
How do you hook in something like code review?
Code review, you can do it in many different gobbledygook ways if you want. What some people do is they'll use vrefs, and people will essentially vote on something. So I've got to change, and I say, okay, everyone vote on it. Other people then essentially commit that to a vote branch. When I try to push it up, it says, okay, here's the change I'm looking for. It goes and looks in the vote branch and sees 1, 2, 3, 5 people have voted for it. Then it's been code reviewed sufficiently. Other people say, we don't want to enforce code review. Some people say, if code review is that important, they probably have a bigger tool they want to run around it, so they want to have something more like Stash that's built in and not using Git event. Other people just say, the format will be, here's my change log, and there will be a reviewed by line, and if there is not a reviewed by line, I will not let it be committed. Now I could lie, I could say reviewed by Mark, and Mark didn't actually say okay, but we'll see some revision history. He'll be like, I didn't say that's okay. He'll come and hit me with a hammer. That could be simple enough. If there's no reviewed by line, then it doesn't get committed. And if you lie about reviewed line, there's a pink slip on your desk. Those are surprisingly effective, those pink slips that has. You don't have to do it once. Other questions?
Is there an equivalent like the Android repo tool to manage multiple Git repositories? Android tree has like 400 Git repositories.
You want to automate it? Because it does handle multiple repos, you just have different stanzas. You can also include different pieces. So you can have something that has what you want for the permission, say, and include that in each of one of the repos rather than including those manually one by one. So you could build the configuration file dynamically, you can use includes, you can use groups. So it can do all that stuff pretty easily.
Yeah, how mature do you think GNU+Linux is, and do you know of any like roadmap features on it?
I don't know that there's a lot of development that's going into it, because I think it's got the feature set that it's looking to have. What I might see is maybe somebody decides, couldn't we write this in Python? And just rewrites the functionality, or maybe some changes to the configuration to make it so like the vref stuff feels a little kludgy here and there. But there are a lot of different things people can add for better vref stuff that's available in the distro, so people aren't rewriting the same thing each time. It seems like it's pretty stable and pretty feature rich now.
I imagine some of the contribute scripts that see some future
Absolutely.
improvements.
Like I said, you could make one that's based on time of day or on IP address, but there's not one that's built in for you. So you'd have to write that yourself, or find it somewhere on Stack Exchange. Anything else? Awesome. I think I got us back on track. Everyone, don't pull the fire alarm. Thank you.
Firewall alarm. Oh no, our computers are secure.
Well, we can kill one now, so I think Bucky's up to six.
Nice.
Or did it keep home in?
Oh.
And we now have no password.
But I have been, thank you.
There we go.